Sabancaya. Sabancaya is an active 5,976 meter high stratovolcano in the Andes of southern Peru, about 70 kilometers northwest of Arequipa. It is considered part of the Central Volcanic Zone of the Andes, one of the three distinct volcanic belts of the Andes. The Central Volcanic Zone includes a number of volcanoes, some of which like Huaynaputina have had large eruptions and others such as Sabancaya and Ubinas have been active in historical time. Sabancaya forms a volcanic complex together with Hualca Hualca to the north and Ampato to the south and has erupted andesite and dacite. It is covered by a small ice cap which leads to a risk of lahars during eruptions. Sabancaya has generated numerous long lava flows especially during the early Holocene, while activity in the later Holocene has been more explosive. Historical reports indicate eruptions during the 18th century. The volcano returned to activity in 1986, culminating in a large eruption in 1990. Since then it has been continuously active with the emission of ash and gas. The name Sabancaya is Quechua and means tongue of fire or spitting volcano, likely a reference to the eruptive activity. The name is attested from 1595, implying that volcanic activity was observed by that date. Sabancaya lies northwest from Arequipa, at a distance of 70 km. The important Rio Calca Valley is located north of the Sabancaya Hualca Hualca Ampato volcano complex. The subduction of the Nazca Plate beneath the South American Plate in the Peru-Chile Trench leads to volcanic activity in the Andes. This volcanic activity presently occurs in three segments: the Northern Volcanic Zone, the Central Volcanic Zone and the Southern Volcanic Zone. There is an additional volcanic belt south of the Southern Volcanic Zone, the Austral Volcanic Zone. Sabancaya is located in the Central Volcanic Zone of the Andes, which extends through southern Peru. Many volcanoes in the Central Volcanic Zone are poorly known, owing to their remote locations and adverse conditions such as high altitude. Sabancaya is part of a series of volcanoes that line the southwestern coast of Peru at a distance of roughly 100 kilometers from the shore. Of these volcanoes, Sabancaya, El Misti, Ubinas, Huaynaputina, Tixani, and Tutupaca have been active during historical time. Further volcanoes in the area with Pliocene Quaternary activity are Sarasara, Solimana, Coropuna, Ampato, Chicani, Ucumane, Casiri, and Tacora. All these volcanoes are considered part of the Central Volcanic Zone of the Andes, and lie 150-200 kilometers east of the Peru-Chile Trench. Notable among them are Ampato and Coropuna for exceeding a height of 6,000 meters, Huaynaputina and El Misti for their large eruptions, and Ubinas and Sabancaya for their recent activity. These volcanoes are found in places where strike-slip faults which delimit the volcanic arc and strike along its length intersect additional faults formed by extensional tectonics. Such faults occur around Sabancaya as well and include the Huamboca Banacond, the Huanca, the Ishapampa, the Pampa Sepana and the Sepana faults. The volcanoes Ampato and Sabancaya are aligned on this fault, which may thus be responsible for their existence. These fault systems are still active and experience occasional earthquakes and deformation. Sabancaya is 5,960 meters high and rises 1,500 meters above the surrounding terrain. It forms a group of volcanoes with the northern Hualca Hualca and the southern Ampato in the Cordillera Occidental, which tower above the Calca Canyon in the north and the Siguas Valley in the southwest. Ampato and the more heavily eroded Hualca Hualca are the dominant volcanoes of this group, with Sabancaya forming a northeastward extension of the former 4-5 kilometers away from Ampato's summit. There is evidence of age progression from the oldest, Hualca Hualca, over Ampato, to the youngest volcano, Sabancaya. Sabancaya consists of two separate centers that are formed by neighboring domes, Sabancaya I North and Sabancaya II South. The summit crater of the volcano lies between these two domes, with traces of an additional crater just northeast. Despite the presence of an ice cap, lava flows are recognizable in the summit area. They have a total volume of 25 cubic kilometers. A set of over 42 Holocene lava flows emanates from the volcano and covers a surface area of about 68 square kilometers, with individual lava flows extending up to 8 km east and west from between its two neighbors. The lava flows at larger distances are older than the ones close to the vent. These flows are blocky, have lobe structures and reach thicknesses of 61–70 meters. The total thickness of this pile of lava flows is about 300–400 meters. Pyroclastic flow deposits are also found, but they might originate from Ampato rather than Sabancaya. Sabancaya, like its two neighbors, is covered by an ice cap which in 1988 extended to distances of 2.53 kilometers from the summit. In 1997, a surface area of 3.4 square kilometers was reported. Moraines at elevations of 4,450–4,250 meters above sea level testify to the occurrence of more extensive glaciation during the last ice age between 25,000 and 17,000 years before present. These moraines have diverted some lava flows. Younger moraines are found at higher altitudes, 4,400–4,650 meters above sea level, and may have formed between 13,000 and 10,000 years ago, shortly after the beginning of the Holocene. Earthquake activity has allowed the identification of a candidate magma reservoir beneath Pampa Sepana northeast of Sabancaya about 10 kilometers away from the summit. Between 1992 and 1996 this area inflated at a depth of 11–13 km below sea level, indicating that the magma supply system of Sabancaya may not be centered directly below the volcano. Indeed, a phase of ground uplift at Hualca Hualca volcano and earthquake swarms in 1990 could indicate that the magma chamber of Sabancaya is actually under the neighboring volcano. The tectonic conditions in the region have not been constant over time. At various times the plates approached each other at higher speed, and this led to a compressional tectonic regimen. In the western Cordillera, however, tensional faulting facilitated the occurrence of voluminous volcanism. This faulting is still underway and produces earthquakes in the area. The basement of the volcano is formed by Precambrian rocks, which are overlaid by various sediments and volcanic formations of Mesozoic and Cenozoic age. Especially during the Neogene, the supply of volcanic material was high and dominated the region, forming a volcanic foot. The present volcanoes are constructed on this volcanic foot. This foot is made out of an ignimbrite plateau that drops down south. The foot beneath Ampato, Hualca Hualca, and Sabancaya has been dated 2.2 plus or minus 0.15 million years ago, while a lava flow beneath the first and the last of these is about 0.8 plus or minus 0.04 million years old. Fresh vulcanites of Sabancaya consist of porphyritic andesite and dacite, which form a potassium-rich calc-alkaline suite similar to other volcanoes in southern Peru. The andesites occasionally appear as fine-grained enclaves. The rocks are not very vesicular and contain a moderate amount of phenocrysts. Minerals encountered in both phenocrysts and ground mass are amphibole, biotite, hornblende, iron oxide, plagioclase, pyroxene, and titanium oxide. Degraded olivine is also found. The magmas formed at temperatures of 929–90 degrees C with uncertainties of 30–50 degrees C. The highest temperatures are associated with the 1992 eruption products. Isotope data indicate that the pre-magmas interacted with the crust at great depths before rising to shallower magma chambers. In these shallower magma chambers, magmagenesis involved processes of magma mixing which formed at least part of the andesites and fractional crystallization which gave rise to the dacites. Partial crystallization and flow events within the magma chamber caused the formation of the andesite enclaves. The total magma production rate of Sabancaya without accounting for repose periods is about 0.61.7 cubic kilometers per year. Sabancaya is a source of volcanic gases such as SO2 and H2O. The amount of water emitted by Sabancaya is noticeably large for a volcano. The source of this water might be an evaporating hydrothermal system in the volcano. Most activity at Sabancaya occurs in the form of lava domes and lava flows, one of which is dated to 5,440 plus or minus 40 years before present on the eastern flank. Additional surface exposure dating has yielded ages of 12,340 plus or minus 550, 6,650 plus or minus 320 and 6,300 plus or minus 310 on various lava flows, indicating that effusive activity started shortly after the beginning of the Holocene. Pyroclastic eruptions are less common and have a low volume. with one such occurrence dated to 8,500 years before present. This tephra layer, along with layers dated 2500 to 2100 BC, 2150 BC, 100 BC 150 AD and between 1200 1400 AD, could have originated either on Sabancaya or Ampato. However, there is evidence that early and middle Holocene Sabancaya mostly erupted lava, while the late Holocene volcano was more explosive in its activity. It is possible that the Inca performed human sacrifices in response to eruptions of Sabancaya to calm down the mountain spirits. Spanish chronicles mention probable eruptions in 1752 and 1784, which might have left layers of tephra. After the 18th century, the volcano went dormant for about 200 years. In late 1986, an increased fumarolic activity heralded the onset of a new eruptive period, and satellite images observed the occurrence of black spots where the ice had melted or boiled away. During this time, the death of animals was observed in the area. This period reached a climax in May 1990, when an eruption with a volcanic explosivity index of 2.3 occurred. This eruption threw ash to distances of 12 kilometers from the summit and was accompanied by strong earthquake activity and the formation of eruption columns that reached heights of 7 km. The eruption and further activity, through 1990, enlarged the summit crater and caused the formation of new rows of fumaroles. Chemical analysis of the volcanic rocks suggests that this phase of volcanic activity was started by the injection of mafic magma into the magma chamber. This eruption displaced between 4,000 and 1,500 people in the region. After the large 1990 eruption, the style of activity at Sabancaya changed towards a frequent occurrence of explosive eruptions with however low output, which threw ballistic blocks to distances of about 1 kilometer from the summit crater. This pattern of activity is referred to as Volcanion Eruptions. These explosive eruptions became less common over time and the proportional amount of fresh volcanic material increased at first. Since 1997, discontinuous eruptions generate steam columns no higher than 300-500 meters and ejected material is almost entirely lithic. Satellite imagery has evidenced the occurrence of temperature anomalies on Sabancaya on the scale of 13 K, probably owing to fumarolic activity. In March and April 2013, fumarolic activity and the occurrence of seismic swarms increased, leading to local infrastructure being damaged. An eruption occurred in August 2014. This pulse of activity was accompanied by an increased release of SO2, which was being emitted at a rate of 1,000 tons per day in 2014. Ash was emitted by the volcano multiple times through 2014 and 2015. A further increase of fumarolic activity was observed in 2016, when new fumaroles appeared and sulfur flux increased to 6,000 tons per day sulfur dioxide. Ash eruptions have occurred since November 6, 2016, with an eruption column 3 km high 5 days later. As of June 2017, a persistent gas plume lies above the volcano and repeated emissions of ash have happened, resulting in several alerts for the local population. Sabancaya rises above the valleys of the Hualca River and of some tributaries of the Siguas River with about 35,000 people living in them. Sabancaya is particularly dangerous for the Hualca River Valley, a major tourism destination in Peru with the towns Achoma, Cabanacondet, Chivay, Ishapampa, Lari, Maca, Madrigal, Pink Hollow, Yank and others. The flanks of Sabancaya themselves include roads and a major power line that comes from the Mantaro power plant and delivers electricity to southern Peru. All of these could be threatened in an eruption. In the case of a major Plinian eruption, at least 60,000 to 70,000 people would be threatened. Rock fall would affect the area close to the summit domes, as would pyroclastic flows. These would be a further hazard to the valleys draining the volcano. The presence of an ice cap is an additional source of danger, as its melting during a volcanic eruption could form hazardous lahars, although the small volume of the ice cap limits their damage potential. The Majas River and Suwaisai River drainages would be threatened by such mud flows in case of an eruption. The former is the site of a major irrigation project. The Peruvian Volcanological Observatory monitors Sabancaya, and has published a hazard map. Aside from the direct threat of eruptions, Sabancaya also contributes to SO2 air pollution in the Hualca Valley, which can damage plants and cause respiratory distress in animals and humans.